Hello, my name is Rez, and I am a professional game programmer, and I do electrical engineering as a hobby. This is the technical video for day 10 of our Robot Advent Calendar, and I have to say, I saw two cables in the bin, and I'm like, okay, this is going to be a real short day. Like even when they're giving us, back here, I don't remember where it was, where they gave us a resistor. They've just they've done a really good job of making interesting stuff, even when the component is relatively basic. So I have to give it to them. The game one that they did, which I have videos for as well, I think 2 years ago, was amazing. The radio one I didn't like as much, but this one, along with the game one, are great. I think this one's my favorite now, and I'm a game developer, so you'd think I'd like the game one better, but this one's really good. I'm really enjoying this, and I think for someone who is new to electronics, who wants to just play, this is a really good introduction to a lot of these, core principles. One really interesting question that this experiment raises, is what is the purpose of this transistor? Because we had the previous circuit right here, right? And in this circuit, we were driving this LED directly here. Light comes in, it lowers this overall resistance, allowing the current to flow. If there's no light, then this essentially acts like an open switch, and so no current is going to flow and the light doesn't light up. Why can't we just do that here? Why do we need this extra step? And the reason why is because of current. So I'm just going to redraw this, just like we had before, where we've got this motor here, which comes down to this guy. And this is our phototransistor. So why can't we just do this? We have some light here that shines there, whatever that's going to be, and this connects to our 4.5 volt source, just like that. Why can't we do this? The problem is with how much current this thing can actually deal with. And the answer is typically somewhere between a microamp and about 10 milliamps. I just searched for phototransistors. You can look it up if you just Google for phototransistor current limitations for a typical phototransistor, likely exactly what we have here. I don't have the part number, but it's likely just a basic everyday phototransistor, nothing special. This is going to be our limit. Now this motor, in my experiment, it doesn't really turn on till you give it somewhere around 150 milliamps, maybe a bit more, and it needs an extra bit to get that stuff going, right? Overcoming the static friction of these physical brushes that are moving around. That takes a bit of extra juice, and then it starts stabilizing, and it can drop down to as low as 90 milliamps or so, even a bit lower. So this can't actually source it, and that's true in a lot of things. Now, a lot of times you have some kind of processor, CPU, PPU, whatever you want, that has some data line, right? And that line you might want to have turn on. You might have some load or something that you want to turn on. So maybe it's something like an LED, like this, or maybe it's something like, in this case, like a motor. Right now, all of these are going to draw current. All of this stuff is going to draw current. And this little output, depending on which CPU you have, is going to be able to source, 10 milliamps, 20, 50 maybe? Depends on what it is. I personally enjoy the Arduino. So here's one of the Arduino boards. Here's another one. Arduino, I think, is a hugely amazing open source little tool. Here's another one. This one's not an Arduino. This is a Trinket, I think it's called. An Adafruit Trinket. It's just a tiny, tiny little microprocessor. It's just that guy right there. Now these are not able to actually source all that much current. It's not very much. I mean, this whole thing draws 500 milliamps. So it's not going to be able to source that much current. In fact, if you try and pull more, you risk burning out the processor. So the processor gets burned out and you're out, however much that processor cost you. That's not what you want. So the whole point of a transistor, of an actual like real transistor, I should say, or I guess a power transistor or an amplifying transistor, or something that is meant for this, one of the transistor's purposes is to amplify current. That's its source, or to amplify the signal that's going through. So a common use case is you have some signal that's coming through and you want to make that signal bigger. And that's essentially what we're doing. We can't source a lot of current coming from this phototransistor. We can get a bit, but we can't source it. So we're doing amplification. All we're doing with this small amount of current is driving this transistor. That's the only thing. Its entire purpose is to drive the transistor. And as we saw before, we only need a few milliamps to do that. And that allows us to have a considerable amount of current flow through here. In our case, 100 milliamps or so. So that's why we have to have this separate transistor. This one's not going to be enough. It's not going to allow enough current to flow through it. So we can even measure it. We've got 2 meters here. This one is measuring the current basically at this junction right here. And then this one is measuring the current at this junction right here. And this allows us to measure what's going on. So let me put these guys right next to each other. So you can see we're at what? 350 microamps. Barely anything gives us quite a bit of current on the output. The other interesting thing about this circuit is how it's designed. And I'm not 100% sure why they chose this. It would be interesting to find out. If someone knows more about why they chose this specific design, I'd be interested to hear it. Because the way that I would design this is more of like a sort of common collector thing. So I would have it come down like this. This is my phototransistor. This would come down to a resistor to ground. And then this would be the point that I would tap off to create the amplifier to come down here, to come up here to drive the motor. So both of these would basically, this would be our 4.5 volts. I would do something a little more like this. We have these kind of things in here. So basically what would happen is if this is dark, there's no light, then the resistance here is effectively infinite ohms. Thus, we're going to get no voltage drop here at this resistor. So nothing is going to be able to bias this transistor, like nothing can flow here. Whereas in the other way around, if we have a bunch of light, we have a little light shining here against this resistance is going to plummet and approach 0. It's not going to be 0. It was in our previous test, it was dropping about half. It was splitting at about half of, I think it was the 470. So it'll still be a relatively significant resistance, but we're going to drop much more voltage across this resistor, which will allow us to have a positive voltage here, our negative differential here. That's going to drive this circuit, which is going to allow more current to be pulled through here, which will drive this. It's the same kind of thing that we're doing. I'm not sure what the exact advantages, if there are any, of this particular circuit are. This feels more like a kind of standard amplifier design. This right here should be fine with the 1K that we have. So I think we already have the components for everything that we need. Because over here we could just have, the other part of this circuit that we had, which was this. I drew a giant resistor for some reason. Right, we have our LED that we had before. This can just be the 470 that we have. So with all of the components that we have, we could have built something a little more like this. I'm not sure why the current direction is the way that it went, but I'm curious. And for fun, I just built that circuit. I built this circuit that I created. I used our 1K ohm resistor here that we had from one of the previous days, and it works. It works fine. It actually works slightly better in that kind of pulling more is driving the motor more. So that might be one thing. I mean, I'm running. I set for safety reasons. I set this to not draw too much current, but I can get this going. I mean, we're drawing about 150 milliamps or so. This thing's cranking pretty fast. This is actually a better circuit in terms of being able to drive more current. So this is more of what I would have expected, but maybe they did this on purpose. Maybe they wanted to limit it a bit more because that would happen here, I think. So that could be it, but this is if I were to reach for something, if I were to do something like this, it's interesting that I would have reached for a very different design. So it's just different ways to design the same thing. But I am curious if the design's going to change, or if something's, I'm just curious where this is going to go. Anyway, that's it. These have been really fun, and I'm really looking forward to tomorrow.